So now, continuing with polynomials, what we're going to talk about now is doing our operations with polynomials, which is going to be that adding, subtracting, multiplying, combining like terms, and all those things that we've actually been doing all year long, but we've never really attached a name to it because it was skills that we had learned in the past. So what we're doing here is we are, again, just reviewing it. Here we talk about adding and subtracting polynomials, multiplying polynomials. What is a binomial? What is a trinomial? We're talking about the closed concept, and then the FOIL method, which is very popular amongst people multiplying binomials. So a binomial is the sum of two monomials, and a trinomial is the sum of three monomials. And we'll look at that. And then a set is closed if and only if an operation on any two elements of the set produces another element of the same set. Adding and subtracting, for example, usually results in a closed operation because you still have the same number of items. So that's what they're talking about. We'll discuss that a little bit as we go through these examples. Determining whether an expression is a polynomial. If it is a polynomial, state the degree in the polynomial. Well, I put these little notes over here as a reminder that this square root thing is how we would reorder that as a fractional exponent. It's not a monomial here or a polynomial here because our variables, our degrees have to be to integers, positive integers, and that is not an integer, that is a fraction. So that's why in this example they said that is not technically a polynomial. It has 1, 2, 3 terms, but not a polynomial. Here, this expression is a polynomial because each term is a monomial. All of my variables are an integer, positive integer, and even this one there's no integer, or you could think of it as x to the 0 or something like that, but maybe that's too much, then we don't need to worry about. The degree, when you have a degree, you would add your degrees. So here we have the degree is 5, here we have the degree is 9. The degree here is 0. So the degree would be the leading would be the degree of the polynomial would be the highest value. So the degree of this polynomial is actually 9, not 5. Let's see here, and this next one, this is also not a polynomial because, again, these are not positive integers, which that's what you have to have in order to have a monomial. So looking at some of these, let's see here, state the degree of each polynomial. The exponent 7, 5, and 0, because it does remind us here, remember that the constant terms have a degree of 0. So this would be a degree of 7. Here, this is a degree of 10. In this one here, we have 7 plus 2 is 9, or 1 plus 1 is 2, so the degree is 9, and then here the degree is 0. And if you have to think about why is a constant the degree of 0, well, I could have written that as 25x to the 0, and we know that anything raised to the 0 power is 1. So that is technically x times 1, 25 times 1, which is just 25. So technically, that's why your constants are your degree of 0, because anything raised to the 0 power would become 1, and it would appear to be just a constant. Now, when we are adding polynomials, you want to group like terms, and what like terms are going to be things with the exact exponents, the exact variables, what makes them like. We x to the first, or we have x to the third here, 6x to the third. Well, we can combine that with x to the third. We can combine the 7x squared minus 4x squared. We're combining like terms. And I will tell you that typically when I do this, Typically when I do this, I set this up as that traditional addition or subtraction problem where I can now just add down. So I know that 5 plus 1 is 6. I know that minus 2 minus 8x is going to be a minus 10x. I know that 7 minus 4 is going to be a 3x squared, and I know that 6 plus 1 is going to be a 7x cubed. It's just easier for me to line things up, and I don't have to worry about, did I get them all? I'm able to see them all that way. So here, and that's what they did here. Now for subtraction, or no, this is just addition. If I do the same thing, I'm going to save myself a little bit of time and space, and I'm just going to say, I'm just going to bring 4x to the third minus 7x squared plus 5x. So I used all those, and when I combine like terms, there was nothing to add to the negative 3 or combine with the negative 3, so I just have minus 3. I have plus 11x. I have plus 2x squared, and then I have 6x to the third, and that would be my answer there when I go to combine those like terms. Okay, and then when we go to subtract, when it comes to combining like terms, really we're going to be adding. We want to get to the addition. Remember your order of operations, and I know this is unusual, but we have our grouping symbols, right? Then we have our exponents, then we have multiplication and division, and then we have addition and subtraction. Well, that's our order of operations, but so if you think about it, before I am able to add and subtract, I must multiply and divide, and this subtraction here is really multiplying everything by a negative 1. So that's why we have to do that distributive process before we can do the adding and subtracting. So with that, again, I would set this up, and I know that they have it all here, but what I'm going to do is I'm going to set it up over here the way that I am comfortable with. Okay, so now I've rewritten the problem. I did add in this 0x to the third that does not appear, but I know that I have x to the third here, so I knew that, when I combine like terms, it's basically a space filler for me. So when we subtract, what do we have to do? We have to make sure that we do the multiplication process first, which is nothing more than if I distribute the negative 1, that becomes a positive because I'm now distributing it. This becomes a negative, this becomes a negative, this goes from negative to positive, and this becomes a negative. Now when I combine like terms, the sign changes have been done for me. So this would be negative 12, this would be positive 10x, this would be negative 9x to the third, this would be 6x to the fourth, and then this would be 2x to the fifth. And that is an easier way for me to organize my problem because I'm just more comfortable adding and subtracting vertically. So that's just, it's just a different approach to what they have done here. And of course, they are showing you all the mathematical thinking, showing you, hey, we have x to the fourth, we group them together and then combine like terms. They have x to the third, bring it down. They have x to the first, they group them together and bring it down. So just a different method. So there you go. Now I'm just going to go ahead and do the same thing here. And what I would encourage you to do is just go ahead and rewrite the problem and try it before looking at your answer. So we should have something along the lines, again, I put a little space saver in here. And I have, when I add down now, I distributed the negative. And then when I add down, I end up with a positive 10, I end up with a negative 3x, a positive 6x squared, and then a negative 5x cubed, and then that would be the resulting polynomial. So there is combining like terms, which is something we've been doing all year long. Now, as we go to multiply polynomials, I just put this one little point of fact up here is that when we multiply polynomials now, instead of combining like terms, we are going to be
multiplying variables and numbers together, and we want to make sure that we're doing the correct exponent operations to where x to the first times x to the first is actually going to be x to the second. So things to think about. There's different methods when we're multiplying polynomials, and the most common that people talk about is going to be the FOIL method. And that is, I will just say, what they talk about is multiplying the first items of my polynomial, the outer items of my polynomial, the inner items of my polynomial, and then the last items of my polynomial, and that's what FOIL is. Another way to think about it is we're doing the distributive property. I am distributing 2x times everything in the other polynomial, or the binomial in this case. So I have 2x times x minus 3, and then I'm going to take 4, and I'm going to multiply 4 times x minus 3. And when I do that, that ends up becoming 2x times x. It becomes 2x times negative 3. It becomes 4 times x. It becomes 4 times negative 3. And then we multiply that out. This becomes 2x squared minus 6x plus 4x minus 12. And then we combine like terms, and this negative 6x plus 4x becomes negative 2x. So that is understanding the FOIL method. And so here, if we look at this, we're going to distribute or multiply. This is an example, and I would encourage you to do this example real quick, stop the video, and then check it out. But we're going to take 3y, and we're going to multiply it by everything over there. And then we're going to take negative 3 and multiply it by everything over here. So let's see, we have 3y times 2y minus 3. Then we have minus 3 times 2y minus 3. And this becomes 6y squared. That becomes minus 9y. This becomes minus 6y. This becomes plus 9. And I have 6y squared minus 15y plus 9. And there you go. That is multiplying two binomials together and combining like terms. So now that is when we have two binomials. It's just a system, a method. But we're going to use, instead of calling it the FOIL method, we're going to use this distributive property again. And in this case, I have a monomial outside of a polynomial, so I am going to distribute and multiply it by everything inside. And that's what they did, and then they turned around and combined like terms. Now, in this multiplying multiple binomials, there is no system intended there. There's no system out there to say, hey, is there some way we can do this? Actually, what you do is you take the first two binomials and you multiply them together, and then you take that resulting trinomial out of those two binomials, and then you multiply it by the last binomial. And that's what they did. So here they took the first two, they multiplied it together using whatever method you like, and came up with 3a squared minus 16a minus 35. Then they turned around and took that 3a squared minus 16a minus 35 and multiplied it by the remaining binomial. And again, doing that distributive property, they took 3a squared, multiplied it by everything here. They took, negative 16 and multiplied it by everything over here. They took negative 35 and multiplied it by everything over here, and they come up with this. You can see they did have to do some combining of like terms, but that's how they did that. So in this example where we multiply 3, I would say that it doesn't matter which one you start off with. You just want to make sure that we take 2, we multiply 2 of them together, and then whatever we get, we're going to take and multiply it times the remaining, or the remaining binomial. So take a moment, and then we will check our answer. So as I multiply those first two binomials together, again, negative 2r times 5r minus 1, negative 3 times 5r minus 1, distributing, going to combine like terms, and now I have a trinomial, and then we're going to take that remaining binomial and multiply it by that, and I'm going to multiply then r times negative 10r squared minus 15r plus 3. And then I'm going to multiply 4 times negative 10r squared minus 15r plus 3. So we have here the resulting minus 10r cubed minus 55r squared minus 57r plus 12. So there, again, I had some like terms I did have to combine, but this is going to be my resulting answer. And it would make sense just understanding that, understanding that we have, this is r to the first, r to the first, r to the first, which we should have then something that is going to be r to the third. And that would tell us just, that's like, this is the factored form that we do have what would be a cubic function. So just some of these things carry forward in their understanding. And then here, goodness gracious, Byron is baking a 3-tier cake for a birthday party. Each tier will have 1/2 the volume of the previous tier. The dimensions of the first tier are shown. Find the total volume of the cake. Okay, so here's the first tier, and then this tier is going to be 1/2 times that, and then the remaining tier is going to be 1/2 times that. So I know tier 1, let's see here, let's go with tier 1 is equal to volume, right? You gotta remember volume is length times width times height. So x times 2x plus 1 times 4x minus 3. And then I know that, let's see here, tier 2 is going to be equal to 1/2 of tier 1. And then I know that tier 3 is going to be equal to 1/2 of tier 2. So that is a good start and gets me into the process of understanding what are my functions going to be. So if I were to, first of all, distribute that out, multiply that out, I believe that the answer, once we do all of our multiplying and combining like terms, should be 8x cubed minus 2x squared minus 3x. Now we're going to multiply that 1/2 times 8x cubed minus 2x squared minus 3x, which would be 1/2 of 8 is going to be 4x cubed. 1/2 of negative 2 would be negative x squared. And then 1/2 of negative 3 is going to be negative 3/2 x. And then we're going to take and we're going to multiply that by 1/2. And that would be 1/2 times 4x cubed minus x squared minus 3/2 x. So 1/2 of 4x cubed is going to be 2x cubed minus 1, negative 1 times 1/2 is going to be minus 1/2 x squared. And then negative 3/2 times 1/2 is going to be minus 3/4 x. And that would be each one of my tiers as I calculated. Now, in order to find let's see here, we'll approach the task. You have learned, what is the total volume of the cake, right? So the volume of each tier and the volume, if I combine like terms, all of these volumes added together will give me the total volume of the cake. And when I combine like terms, I hope we get 14x cubed minus 3.5x squared minus 5.25x. And then that will be the total volume. So just thinking about how do we, sort of wrap all of that stuff together. Ultimately, this kind of question, this is the end goal of Algebra 2. This is a grade level question, and that's what we want to be able to do, is understand how to multiply things together in the application process, figuring out what my
question is telling me and then answering those. So we'll get a little practice in class here.